the cardinality of a set is the number of distinct elements of that set. And we denote it by these bars around the set. So a simple example here, let's say you have the set A, B, C, D. Then the cardinality of this set is going to be the amount of distinct elements. So in this case, it has 4 distinct elements, A, B, C, and D. And so the cardinality of this set is 4. Now, let's look at the cardinality of the following set. 1, 2, 2, 3. Now, one might think, just looking at it, being like, oh, maybe it's 4, but it's not, because again, let me emphasize this, distinct elements. And so the distinct is quite important. So here, there might be, I might see 4 things, there are 4 numbers that are written here, but this set has only 3 distinct elements, the element 1, the element 2, and the element 3. Because remember that for sets, we do not count how many times elements appear. The only thing that matters is that they are in the set. So this set has cardinality 3. Notice also that this set, so this set here we had seen before, is equal to this set here. And since they are equal, of course, their cardinalities have to be equal. And so one shouldn't be that surprised, I guess, that it has cardinality 3. The empty set has cardinality 0 because it has no element in it. Remember that the empty set, you could also write it as the set with nothing inside. So it doesn't have any distinct elements, so it's just 0. And then you have, so these are all finite sets, and finite sets have, I guess, that simplicity to them. It's a count of what's inside. With infinite sets, things are a little bit more complicated, maybe. You have different types of infinity, which we won't get much into here today. So sets like the natural numbers, right, the counting numbers, the integers, and let's say the rational numbers. Let me write this better. So they are what is called countably infinite, which essentially means that they can be counted, which essentially means that they all have the same size as the counting numbers, the natural numbers. But there are also infinite sets, like the real numbers, where they are what's called the real numbers. This is uncountably infinite, where you can show that there's a sense in which they are actually larger than the natural numbers. But that's not going to be the focus of the video today, but I think it's worth mentioning since we're talking about cardinalities. So for now, cardinalities, you're counting the amount of distinct elements. When it's finite, I guess it's quite natural to think of. You just count them. When it's infinite, counting infinite stuff is a subject of its own. So for now, let's not focus too much on that.